Hi there, welcome. My name is Andrew Gardner. I'm product marketing at Lightstep, and with me today is Danica Shea, platform product manager at Lightstep. Lightstep is a monitoring, observability, and incident response platform that enables reliability at scale for DevOps teams around the world. Built by the team that launched observability at Google, Lightstep has been driving intuitive cloud-native observability to immediately identify and understand every change in the complex cloud-native apps that power businesses since 2015. And in 2021, we were acquired by ServiceNow. With our recent acquisition of Era Software, we are excited to be building the next generation of observability with fully integrated metrics, logs, and tracing data built from the ground up. We're building a unified and seamless observability experience within one solution, designed to scale with your business, allowing deep insights into system performance and behavior, even with a rapid rate of change. Lightstep empowers app dev and SRE teams to deliver constant innovation and outstanding customer experience, understand and resolve complex issues across any number of services, platforms, languages, or teams, and to collaborate to resolve issues in real time. We're here today to talk about our latest update to the Lightstep platform, Lightstep Unified Query Language. Lightstep UQL powers unified observability as code to help your teams manage the end-to-end pipeline of instrumentation, from definition to management of outputs. And since it's embedded across the entire platform, you can use UQL wherever you are in Lightstep to query and correlate across metrics, logs, and traces on demand. In just a moment, Danica is going to walk you through this announcement and what it means for you and your organization's approach to observability. Over to you, Danica.
Hey everyone, I'm Danica. I'm a group product manager for the platform teams at Lightstep, and I'm excited to talk about UQL today. UQL is Lightstep's unified querying language for querying span and metric time series data. And so the same way that you can build queries using the query builder in the UI, you can express that same query in UQL. So I've created a notebook here to demonstrate some of these examples. And so here's a query showing the CPU utilization group by host. And so with one easy click, you can toggle over to the text editor while preserving that same original query about your CPU utilization. So you can click back and forth. I'm going to go back into the builder and then back into the editor. And you can see that it's represented in both the builder and UQL. And so it's really easy to start building your query in the builder first. And if you're curious about the UQL equivalent, you can just toggle over to the text editor and see the UQL representation for that same query. UQL is embedded across the entire Lightstep product. It's available in notebooks, in dashboards, alerts, and our public APIs. So what are the key benefits to UQL and what problems does it solve? The first benefit of UQL is that it enables users to create more powerful dashboards, alerts, and ad hoc queries. The advantage of UQL is that it's much more expressive than the UI-based builder. It's got the power of all of these additional operators and capabilities that we've built in. And so users can express advanced questions in a very concise and readable syntax that's symmetric across both spans and metrics. So examples of more advanced questions that UQL can answer are, for example, show me the top or bottom 10 hosts by CPU utilization. And this is utilized using the top operator. Another question that it can answer is show me the latency of the service operation time shifted over by 1 week so that I can directly compare the latency for this current hour to the same hour 1 week ago. And this is using the time shift operation that you can see here in the second query. You can also aggregate across pretty meaningful span labels. So for example, you have a span label for error code, and you can now query for the prevalence of the different error codes in your code base and see the distribution as a heat map. In the Lightstep product, UQL will be supported in all features, notebooks, dashboards, and alerts. So these queries that I'm showing you right now are in our notebook that I put together. If I jump over to the dashboard and open one of these dashboards, I can show you the query. This is in the UI-based builder format. And if I pop over to the editor, you can see the same representation in UQL. And then jumping over to alerts, it's really the same thing. So if I open one of these alerts over here, open up the query, pop over to the text editor, you can see the UQL representation here as well. Another benefit of UQL is that it enables users to manage their Lightstep dashboards and alerts as source code. So we can integrate observability into their unit infrastructure as code pipeline. The mindset of everything as code is becoming a best practice and status quo in modern engineering teams because it allows them to accelerate developer velocity by improving maintainability and repeatability. And so developers and SREs, they want to be able to codify their dashboards and alerts into their Terraform configuration files, similar to the way that they may already codify their infrastructure configurations. So UQL has the power to express all of the questions that users want to ask of their systems, whether they are the typical everyday user or the power user. And so within UQL, you can express your query, copy it, jump back into your Terraform configuration file, and then copy that into your configuration file. And so here is an example of a Terraform file with that same query. Another major benefit of UQL is for organizations that heavily rely on APIs to get things done. So there are a growing number of enterprise customers who want their observability vendors to offer a more flexible platform approach. And so they emphasize the need for APIs and a querying language that offers that extensibility and compatibility with their existing monitoring ecosystem. And so UQL supported APIs provide a deeper interoperability with customers' existing tools. For example, within our customer base, Grafana is a powerful visualization tool used by many of our customers. And so we hear from a lot of them about how they want to keep Grafana as a dashboarding tool, but leverage Lightstep's powerful time series database. And so this is why we created the Grafana plugin that leverages UQL supported APIs. And this allows customers to pull Lightstep metrics and tracing data into their Grafana dashboard. And so customers can query for their metrics or tracing data in Grafana using UQL. We also offer an integration with Noble9, which is an SL platform that connects reliability metrics to business goals. And then our UQL supported APIs also allow you to programmatically build out dashboards, create alerts, notebooks, take automatic snapshots, and then retrieve time series data points. Hopefully this overview gives you a better understanding of why we built UQL and what problems it solves. And so from here, I want to dive a little bit deeper into the language itself. And I will first cover the fundamental time series operations. And these are the fundamental operations that you can perform on a time series. And thinking about operations in these 4 ways is a pretty helpful framework for categorization. First, if you're writing a time series query language, you need to be able to fetch a set of time series that you want to operate on. So fetching metrics is a start to every query. You need to be able to retrieve time series data before you can perform other calculations on it. And so this drawing shows 2 time series that are being fetched, one with a host label of 1, 2, 3, 4, and another one with a host label of 5, 4, 6, 7. Once you fetch those time series, there are a category of operations that can modify each point. So these operations look at an individual point and then they perform an operation on it. And so, for example, you can multiply a point by 1,000, and that takes you from a kilobyte to a megabyte if you want to convert it to produce a new point. This is also called a point-wise modification. Another class of operations is modifying an entire time series instead of just a single point. So you might want to do some time series modification. You want to shuffle points around, or you want to combine groups of varying time points and align them to evenly spaced points. And then this last group of operations is cross time series operations. This is about joining multiple time series, synthesizing a new time series, dropping a time series, combining time series, as you can see here, or splitting time series. Next up, I'm going to walk through the anatomy of a very simple UQL query. And so these examples that I'm about to show you are actually queries that you can express in the query builder. There's a lot more power behind UQL, but for the purposes of demonstrating syntax and structure, we'll keep these next examples more simple. And so this is a pretty standard UQL query. You can see that the UQL operations are linked together using the pipe command, where the output of one operation becomes the input to the next. Linking operations makes it possible to build up complex queries incrementally and intuitively. The first stage is a fetch that fetches the specified metric. The second stage is an alignment. All the data from the fetch comes back in varying time points, and so the second stage will align them to evenly spaced points. The third stage is an optional stage. This allows folks to filter out certain metrics based off of label values. In this case, we're only looking at requests where the service equals web. Finally, the last stage in this example is a group by stage. So we're interested in taking these web requests and breaking them down by method, adding together all of the requests for every single method. And those are the lines that I'd like to chart. With that, we can jump into those stages in a little bit more depth. And so stages are the key to building out complex expressive queries. Stages are essentially like steps. They're very iterative. So each step does a little bit of work to modify the data from the previous step. The first stage in UQL will always be fetching the data that you want from the database, and subsequent stages will transform and align that data into more evenly spaced points, and then ultimately get rendered as a chart, a number, or other visualization. Digging into fetching metrics. Fetching metrics is a start to every query, and these are the two operations that you can use, metrics and spans. And so you can either view time series using metrics as the data source, or you can view time series where spans is the data source. And so when spans is the data source, this is how we take your trace data and turn it into time series data. If we move on to aligning metrics, the time series that we're collecting from our customers are stored at various time intervals. So alignment is what takes that data and transforms that into regular time intervals. So you can imagine in this example, the aligned data versus the unaligned data. If you take this data and you try to group it without any alignment, if those time series points are not at the same time for both of these groups, then you wouldn't be able to combine those time series together. And that's why aligning metrics is so essential, because you need that before you can perform additional calculations on this time series. And so there are a number of ways that you can align your data. Alignment operations that we support include rate, latest, delta, and reduce. Moving on to filtering. Filtering is pretty intuitive. Once you've selected the metrics and aligned the metric, you can filter certain metrics out based off their attribution or tags. So you can filter using common evaluators like equals, does not equal, and we also support regular expression matching as well. The last step in this example is grouping the data. So we want to take those web requests and break them down by labels that we're interested in. In this case, we want to group by method. So for all of the time series with the same method name, we're going to reduce them into one time series per method by summing them together. Okay, so I'm going to jump into the product to demo the same query that we just went through, and we're going to slowly build up the same query. And we're going to show you operation by operation what we're doing. So first here, this query fetches all of the time series and the request metric and calculates the rate for them. And so you can see this is a pretty busy chart because it's basically pulling all of the time series with requests. And so as a developer, this is not super meaningful to you because it's a ton of data. And the goal of UQL is to slowly refine this query until you get to the data point that you're interested in. So moving on, this is the same query, and now we've added a filter service equals web. And you can see that we filtered out a bunch of services. Anything where the service is not equals to web, we've removed that time series from the chart, and we're getting closer to something that could be a little bit more readable. And now we've added in a group by method. And so this will delete all of the labels that are not method. And then for all of the time series with the same method name, we're going to reduce them into one time series by summing them together. And so each line that's drawn on the chart now represents a method. And so this one shows about roughly 8 or 10 methods. And so this one is the method API get store. And then lastly, I just wanted to show you guys that we have a robust set of documentation on UQL and its supported operators. This reference doc is a deep dive on all of the incredible functionality of UQL. For users that want to really quickly jump in, we also have a one-page cheat sheet that provides a description of all of the operators and also a ton of examples. So UQL is the culmination of multiple teams at Lightstep, and we're super excited to share it out. We want to enable users to express more powerful queries in their dashboards and alerts. We want users to integrate monitoring as code into their observability pipeline. And then lastly, offer a deeper extensibility with customers' monitoring ecosystem. And we're super excited for everyone to check it out. Thanks.
Thank you, Danica, and thank you for joining us today to learn more about Lightstep UQL. At Lightstep, we're creating the most complete, unified primary observability platform in the market, providing holistic end-to-end visibility to turn real-time insights into action. Our teams are hard at work putting log management, tracing, and metrics under one roof for key observability use cases, and we're excited to have you on this journey with us. To learn more about Lightstep, check us out at lightstep.com or on Twitter at LightstepHQ. Thank you.